नमस्कार दोस्तों, इस वीडियो में आपका स्वागत है। जैसा कि पिछले वीडियो में हमने देखा, अगर आपने आज आप इस वीडियो हमारे चैनल पर नए जुड़ रहे हैं और आप पहली बार देख रहे हैं तो आप पुराने वीडियो जो है हमारे चैनल पर जाके देख सकते हैं। आज का टॉपिक जो है वो ये है कि हमने अभी जस्ट इसके पहले जो वीडियो हमने अपलोड किया उस वीडियो में हमने देखा कि अगर हम हमने जनरली क्या होता है 2D मॉडलिंग में हम अपस्ट्रीम बाउंड्री कंडीशन देते हैं, डाउनस्ट्रीम बाउंड्री कंडीशन देते हैं। वी प्रोवाइड द फ्लो डेटा टू अपस्ट्रीम बाउंड्री कंडीशन एंड नॉर्मल डेटा टू डाउनस्ट्रीम बाउंड्री कंडीशन, and we will visualize like water first fill this channel, and after that if water or flow is much more comparison to the capacity of the channel, then water will spill out from the river and inundation start from the river. Like this type of inundation is called river inundation or riverine flood, you can say. But if you want to know if rainfall is taking place to this area, then which area will inundate and what inundation will take place by the rainfall. Okay. Okay, so when in previous video I have just applied the rainfall and run the model and see this result. This is the maximum inundation you can see here. Okay, this is the maximum inundation. You can see here I have applied a rainfall of 11 or 12 hour rainfall I have given to the model, and model just mimics and it gives like precipitation. You can see this type of precipitation increases, this runoff and inundation. You can see the visualization of the inundation you can see on the basis of rainfall. But you know that I didn't provided any type of soil, any type of land cover, any type of curve number, anything I didn't show. I didn't give this to I didn't give all these things to the model. Okay, like when precipitation takes place on the ground, if you are from hydrology background, then you can understand when precipitation takes place or rainfall takes place on the ground. So first of all, before going to inundation or when it touches to the ground, first it try to moisturize the soil. So which type of soil is there? First of all, we have to give the soil to the model, and where it is impacting on the ground, that is which type of LULC is there, land class, which type of class is over there, like if there is impervious or built up area or agriculture area or water where the rainfall is striking to the ground. So you have to give imperviousness of the ground where water is striking, and you have to if you talk about in a broad manner, you have to give curve number of the surface, and curve number is based on soil and LULC. Okay, soil and LULC. So on the basis of soil and LULC, you can give the curve number to the model. So how you can get the curve number from soil and LULC, I will explain it later in this video. And next one, you have to give the Mannings as well. Like you can give Mannings as well, and in Mannings you can give the other parameters. So first of all, I will show you something, and after that I will explain the other things. So here you can see that you have to import here in map layer. You have to click right click on here. You can see here create a new RAS layer. Here this is the land cover layer. If you have LULC layer, you can click on this. You have to add the land cover. Similarly, soil layer you have to add, and if you have curve number layer, you can add directly your curve number here. Okay, so what I did, I have added this curve number as an infiltration layer. Here you can see that this curve number I have added. So in the curve number, as I told you, the curve number can be generated using land cover class. Here this is the class, built up class, where and rangeland, vegetation, water, forest. Okay, so on the basis of these and soil, you have to give the curve number for MC2. Here curve number I have given for no data, I have given 100. What is no data, I don't know. uh, let's take it 100, and these are our class. So here you can give built parent. For that I have given the curve number on the, like you can see from the research paper, and for this area from the research paper, and anything from the handbook, you can get these things very easily. And on the basis of this I have given abstraction ratio. Abstraction ratio means how loss will take place at that point. Like here there is 0% loss. You can see if water rainfall is directly coming to the water surface, then it means there will be no loss. And if it comes in in vegetation, then there will be some loss. This curve number also, so if the curve number 100, it means total runoff, but here there are no total runoff. Similarly you can see here, and from that minimum infiltration rate also you can see here. Here there is no infiltration, as it explains, there is water, infiltration is choked over there, there is constant infiltration is taking place over there. And similarly for vegetation, there is infiltration rate 2 mm per hour. Then there is infiltration rate where water stops for more time, their infiltration will be more. In forest area infiltration will be more, but in built up area there will be very less infiltration. So less infiltration takes place here. So this is the data you have to provide to the model, and how this data I have created, how you can create all this data. So first this one I have provided, and second this is land cover I have provided to the model. So here land cover, when you provide land cover, you have to give the mannings and percent impervious as well. Okay, so here built up have mannings I have given 0.03. You will also get from handbook and research papers this value mannings for all the you can also get from HEC-RAS tutorial, HEC-RAS manual as well for mannings value for all these things. Okay, so similarly for this percent impervious is what percent impervious. There is in a forest area there is no imperviousness, all is there is pervious soil, pervious. In water it is showing 100% impervious, means total water will be account in the runoff. So this type of things I have given to the model. So this is nothing, you have to just import your land cover here, and you have to just assign this mannings and cross-resistant impervious. And after doing all these things, you have to go here in geometry, and you have to click on this, and your geometry is this one, geometry 2D rainfall. And so I'm using terrain clone. Terrain is terrain clone because I have done some modification in this terrain. And land cover, for minings I am using land cover layer, which is in map layer. And for infiltration I am choosing this layer where the model can get infiltration. For imperviousness I am also taking this layer, minings land cover layer, from where the model can get the percentage imperviousness. After that I have to click OK, and after that I have to run the model. When you run the model for this, after applying all these things, you will get this result. Okay, so what is the difference between both results? I will show you here. Let's see the difference in depth. So here you can see this is the difference between depth. You can see here the upper is 2D rain, when I didn't apply curve number and percentage obstruction, everything, and I didn't apply anything. Then this curve follow depth curve, depth is following this curve, and maximum is 0.64 approx. And when I applied abstraction, infiltration, everything, the maximum is 0.49 or 0.5 meter depth is there. Okay, at that point. So this is the difference between when you apply all the parameters properly, then this will give you the proper result. So here this is the difference, and that's it from my side. Thank you. We will see the other things in next video, which I leave here. And